The Transmission Control Protocol is one of the core protocols on the Internet which provides a reliable, ordered, and error-checked stream of bytes between applications running on computers across a network. If UDP is like a letter passing through the postal service, TCP is like a phone call. When I want to talk with someone on the phone, I dial their number and their phone rings. When they pick up the phone, they say hello. Then I confirm my presence by saying hi. At this point, I've established a connection between myself and the other person, and the dialogue starts. I might say, "This is Kirk," to which they might reply, "Hi, Kirk." Then I'd launch in with, "I'm calling because blah, blah, blah," until the conversation ends, and we'd both say goodbye. Using a similar protocol, TCP provides the means of establishing a connection and provides for the ongoing bidirectional transfer of data between two endpoints. A TCP header, which is comprised of 20 bytes of data, looks like this. The fields of importance to NMAP are the source and destination ports, sequence number, acknowledgement number, and flags. The source and destination ports function identically to the source and destination ports in UDP and need no further discussion. The sequence number is a count of the bytes exchanged by the two endpoints. The receiving system, which may receive bytes from the data stream out of order, uses the sequence number to reassemble the data packets back into the correct order. The receiving system uses the acknowledgement number to confirm back to the sending system which packets have been received. The flags or control bits are used to indicate the type of packet or call attention to other significant conditions. The flags that we need to be familiar with are the urgent, acknowledgement, push, reset, synchronize, and finish flags. Rather than define them now, I'll wait and let the context of our first use define them. They'll make more sense then anyway. Since this probably makes little sense from just the definitions, let's walk through a connection sequence to help clarify these fields and increase our understanding of the protocol. A client initiates a TCP session by sending a packet to a server with the SYN flag set. The SYN flag indicates to the server that the client is attempting to establish a session and that the sequence number set in the packet should be used as the initial sequence number for the data stream originating at the client and going to the server. The server responds with a packet that has both the ACK and SYN flags set. The ACK, or acknowledgement flag, indicates that the value of the acknowledgement number is significant in that it acknowledges and confirms the initial sequence number set by the client. The SYN flag indicates that the sequence number in the packet should be used as the initial sequence number for data originating at the server and flowing to the client. The client responds with a packet with the ACK flag set, which acknowledges the server's initial sequence number. These three packets, collectively called the TCP three-way handshake, serve to establish a connection between the client and the server. Both systems are now set to sequence and track the data packets from the other system. We're ready to begin passing data. Data can now flow freely between the client and the server. The sequence numbers and acknowledgement numbers are incremented and confirmed with each passing packet, until we have no more data to pass. When either system is ready to terminate the connection, it sends a packet with the FIN flag set. The receiving system acknowledges the FIN with an ACK and then sends a FIN packet of its own. The final packet of the session is one last acknowledgement, and the session is done. NMAP has two options for performing host enumeration using TCP packets, the -PS and the -PA options. Both of these options operate on port 80 by default, but other ports, lists, or ranges may be specified. Notice there's no space between the option and the port specification. On a Unix system, only the root user is able to send and receive raw TCP packets, which are used by these options. If you execute them as a non-root user, NMAP will enable a workaround so you will get some results, but these options are best executed as root. The following discussion assumes root privileges. The -PS option sends a TCP packet with the SYN flag set, just as if we were trying to initiate a connection. For the purposes of host enumeration, one of two conditions are possible. Either the port is open or the port is closed. Finding that the target port is open is rare, but when it does occur, the target will respond to our SYN packet with the standard SYN ACK reply. This confirms to Nmap that a system exists at that IP address, and therefore Nmap has no further need of communicating with the target system. And so instead of completing the three-way handshake with the final ACK, Nmap sends a packet with the reset flag set, which tells the remote system to tear down the connection and terminate communications. This type of connection, where we abort the session after the first SYN-ACK reply, is often referred to as half-open scanning. The network and transport layer headers for a TCP probe packet look like this. The source IP address is set to the IP address of the testing system, which in this case is 192.168.53.35, and the destination IP address is set to that of the target, 192.168.53.201. The source port is set to an ephemeral port, in this case 7233, while the destination port is set to the target port number of 80. The sequence number is set to a random number and the SYN flag is on. If the target part is open, the reply will look like this. The source and destination IP address and port numbers have been swapped. The acknowledgement number is set to the incremented sequence number from the original probe, and both the SYN and the ACK flags are set. This is the second packet in the standard three-way handshake. The other possibility is that the port is closed, which is common. In this case, the remote system doesn't reply with the standard SYN-ACK packet. Instead, it replies with a reset packet, indicating that communication with that port is not possible and that the connection attempt should be aborted. Notice this is different from UDP. Scanning a closed UDP port results in an ICMP port unreachable message. With TCP, the error is handled within the protocol with the reset flag. In both port open and port closed situations, we receive a packet wherein the target's IP address is in the source address field of the IP header, which positively confirms the existence of a live host at the target IP address, so Nmap reports the system as up. Scanning a closed port, the response will look identical to the port open response, except the reset flag will be set instead of the SYN and ACK flags. The -PA option sends a packet with the ACK flag set as if we were in the middle of a communication session with the target. This packet is spoofing an acknowledgement to data that never existed. The remote system is of course going to have no record of needing an acknowledgement and responds to the testing system with a reset packet, asking that the client's fictitious session be discontinued. This response is exactly what Nmap is trying to elicit, since it confirms the existence of a system at that target IP address. This probing method purposefully deviates from the standard packet sequence defined by the TCP protocol in an effort to deceive and evade filtering devices. We'll come back to this subject and talk more about firewall evasion in a later module. Occasionally, it is desirable to disable host enumeration and have Nmap run a port scan on every IP address you provide. The -P lowercase n option disables host enumeration completely. Here's an example of Nmap using all the host enumeration options we've discussed in this module. The first three options, -PE, -PP, and -PM, all send ICMP request probes. The -PU option sends a UDP probe, and the -PS and -PA options send TCP probes. As an example, the results are a bit boring, since the only output is the brief message, "Host is up," but from a network auditing perspective, that simple message is extremely valuable.